Hello, candidates. Very good evening. So this side Ankit. I hope everyone is doing well, right? So just let me know, am I audible? And let me just share my screen as well, right? Okay, so how like your overall practice is going on? Hello, Nisarg, Spurti, Tashri, Karuna, and the rest candidate. Can anyone confirm me, am I audible or not? Class, then I'll continue. Karuna, okay, got it, Spurti, right? Okay. So guys, what we are going to start today, right? Okay, so in the last or like in the old classes, we have covered the multiple things in the machine learning, right? And it was all closely related to supervised machine learning and unsupervised machine learning, right? Now, what are the things that we are going to start today? Whatever the model that you have built, the management generally wants you to present that model or like the final outcome in a form of website, right? So whatever the model that you have created, you will not generally show the final output like in this code format to the client, right? The client generally want, let's just create the website, and if you just give the input on that particular website, the website generally give you that the final output or the prediction, right? So our today agenda is to understand the model deployment. So what we will do, we will try to create a basic model, which we have already discussed in the previous classes, right? And then we, with the help of some modules that the Python gives, based on that modules, we'll try to deploy our model, right? So the today's topic is how to deploy ML model using Streamlit, right? If you're good to go with this now, then you can probably create any model, whether it is supervised or like unsupervised machine learning, and you can show the final portfolio project to the client or to any of the companies that you're applying for, right? So let me just share this notebook with you. First of all, you can click on this connect. Okay. So you can take help of this link if you want to do the practice parallelly, right? Okay. Perfect. Now what I'll do, I'll just simply pick a basic ML model because our main agenda is to how to deploy the ML model using Streamlit, right? So let's just pick the basic model, and for that I'll use the iris flower classification, right? So the project is iris flower species classification, and we know that it is a multi-class classification project, right? So iris is a flower. We have already worked on this data set, right? And we have to predict final class of the given data set. Okay, now let me just show this data set. The data set is somewhat, we have sepal length, sepal width, petal length, and the petal width kind of information. And you will just feed out this data to the model, right? The model will generally take this data or like sepal length, sepal width, petal length, and petal width. And based on that data set, you have three different species of this flower. The first species is Setosa, second is versicolor, third is virginica, and there is no set of fixed order, right? You can just call any as a first order, right? So this is the data set looks like. And let me just call this the different flower species. You can copy the image as well. And let me just click on this text. So we will use this for the final project deployment, right? These are the different species that we need to predict based on the given data set, which is petal and the sepal information, right? Okay. Now let's just start with the basic part, that is step one, to load all the modules, right? Okay, so I don't want to waste time. So what I'll do, I'll just simply go to this one. I'll call all the important modules because this is a part of like the multi-class classification. So there is no requirement of calculating all these errors or loss, right? You have to call the any of the model because we have performed multi-model approach now, so you can use multi-model approach as well. Let me just call the multi-model things as well, right? So from sklearn.linear model import logistic regression, you can just call from, I'll use some three different models as well. Like the first one is decision tree. You can just go to this from sklearn.tree import decision tree classifier, and let's just simply call the ensemble technique, and inside this ensemble we have the random forest, right? Random forest is nothing, just an ensemble technique where you can just create a bags or boost kind of algorithm of multi-model approaches, right? So we are just going to use 3 models right now. You can call the multi-models. We have performed like support vector classifier as well. Okay, the KNN classifiers, right? You can use the knife based model. You can use the different boosting algorithms that we have already performed, right? So just for sake of understanding how to deploy the model, we are just using the 3 different models, right? Okay, so let me just call the different matrices. The first one is like the accuracy score. The second one is like the precision score. And the third one, you can use the recall score as well, but let me just directly call the classification report, or let's just call the recall score as well, right? Okay, perfect. Import warning, import OS, let's just call some time modules as well. And you can use import date time as well, right? So when you work as an ML engineer now, so you have to call multiple models, or like if you're working for the deep learning as well. So there is a requirement of multiple models things, right? Okay, now let's just quickly call the data set. And you know that you have the data set in a form of from sklearn and dot datasets. You can call the load iris dataset, right? You just call this load iris. And what I'll do, the second step is to load the data set, right? So step 2 is to load data set. I'll do it very fast, right? Because the main approach is to understand the streamlit concept, right? So data set is something like this. Data is equals to load iris. You can just call this to data of data is the like the X data set, and Y is like your data of target is the Y data set. Okay, you can just run this. You have converted this data set into 3 different parts. Okay, now you can get the all the classes as well, right? So if you want to convert this to data frame now, so you can call this pd.data frame, just pass this X, and inside this columns, you can go to this data part, and you have this which is called the feature name, right? The feature names will give you the overall features of each and X data set, right? Sepal length, sepal width, petal length, and petal width, right? So let me just store this inside the DF, or you can just simply store this inside X as well, right? So instead of this one, let's just use this one for the X part, right? Okay. What about the target classes? Because we know that this is a multi-class classification project, so you can just simply use this one instead of just simply call this data of data, right? Perfect. Now inside the data target class, you have 3 different iris flowers. The first one is Setosa, versicolor, and virginica. So you just go to this data, call the target names, and this is the target names. And let me just show this target class, right? So we are having the 3 different classes, arrays like array Setosa, versicolor, and the virginica. We have already divided into data X and Y part, right? Okay. Now, if we want to do some perform EDA, so we can do this, right? Let me just simply call the sns.pair plot, okay? And inside this pair plot, you can simply give your data set as X, and you can show this data set. This will try to show the different kind of scatter correlation with different set of X features that you have, right? It's like sepal length versus petal width, sepal width versus petal width, and so on, right? Okay. See, we are not going to perform the like rest of the EDA part because our main agenda is to how to deploy the ML model. I hope everyone is getting my point, candidate, right? Is that clear? Perfect. Okay. Now let's just call the train test split, right? So what I'll do, I'll just simply call train test split, and inside train test split, you know that you have to give the X and Y data part. You can just simply call the random state. Random state is of 42. And let's just call the test size. The test size is something like this 0.2. It's like 20%. And you know that this will give you the 4 outcomes, that is X train, then separated by X test, Y train, and then finally Y test, right? Once you run this, you'll get this data set split it into 4 different parts. Okay, now what I want to do, I want to follow the multi-model approach now, because we have called the 3 different models. So you can just do one thing. You can call the all models like this one. The first model is something like your logistic regression. So let's just call this logistic regression. The second one is decision tree. And the third one is a random forest, right? And you can just call the all models names as well. And let's just copy the entire different models. and just simply give this as a name, right? The first one is logistic regression, second one as a decision tree classifier, and third one as a random forest classifier, right? Why we are doing this? Because we want to run a loop, and that loop will generally tell, okay, we are going to use this model for the training kind of aspect, right? Let's just cut this data set, and we'll try to run the for loop over this all models name, right? So for I in range of length of, you can pick any of the models, like all models, and you know that since you are only having the 3 models now, so this loop will continue up to the third iteration, right? You can just run this, right? 0 1 2. Okay, so what I want to just first run my train test split, right? So during each iteration, I'll try to like use the random state of different random state, or you can use the random state as 42 as well, or you can use the random concept as well for the different set of random state, right? If you want to do this, so you can just normally call this as np dot random dot randint. And the random is something, it will try to randomly initialize some values, and let me just run this as a 1 to 100, right? This is like my random state. It is completely based upon the random values, right? Now, once you converted this data, or you splitted the data set into training and testing parts, so you can just call this print training ML model using, and you can just use the f string, and you can just call this I index value. And you know that the I index value is thus the 0 1 2 if you want to call the model name. So how to call model name? You know that the models name are generally stored in all models name, and all models name you are having only 3 models: logistic, decision tree, and the random forest. And if you just call the 0th index value, so it will just call the I value, and the first iteration value is the 0, so it will call the logistic regression, and you'll get the model name as a logistic regression. Why we are calling this? Because we want to print this training ML model using model name, and the first model name is the logistic regression. So it will run the loop. The first is like training model using logistic regression, the second iteration will be like training model using decision tree classifier, so and so on, right? So now let's just call the model as well. So model is equals to, again, you can just call this all models, and inside this all model, you have to give the index value. The index is like 0 1 2, and you want to initialize the model, so you have to run this. We know that now, whatever the model that we are calling, we have to give this bracket to initialize those models, right? Okay, now just simply call the fit method. Inside the fit method, what you have to you have to give the simple X train and Y train, and you know that this will return you the score, model dot score. The score is like training and testing score, so you can give your training and testing score to the final comparison, right? X train and Y train, it's like your training score. So let me just store this. This is like the training score, and same as it is with the testing score. And the testing score, for that you can use this X test versus Y test. Let me just simply change this to X test versus Y test. Perfect, right? Now, once we trained a model, once we fit a model, we'll get the training and the testing score. Now, what we want to, of course, predict the Y value, right? So what you can do, you can just simply call the model, you can predict the value. And how to predict the value? You have to give the X test, right? So X test will generally give you the Y predictive value. So you can just simply call this the Y pred. And you want to store some information like the precision score, accuracy score, recall score, confusion metrics, and all, right? So I can just simply call this a ACC score. It's like the accuracy score. Let me just call this accuracy score, and you know that it generally asks you for the Y test versus Y pred, right? And let's just copy this, paste this, and instead of this accuracy, I'll just simply call the precision score this time. So the precision score something like this. Why I'm doing this candidate? Because I want to run the iterations multiple times, like the 3 times, because we have 3 different models. It will try to calculate the score, precision, accuracy, and then we'll probably store all the information inside the comparison dictionary, kind of like this. Okay, let me just, and this, it's like the compare dictionary where we want to compare a model, right? So the first is like your model name. Okay. So the model name, you can just use the empty list. You can like pass your model name here, right? The second is like the random state that you can give. Okay, so let's just call this as a random state, right? And the second is as a model name. And what we are going to do, candidates, You can use the empty list, and instead of directly using it here, now let's just do one thing. Let's just cut this here and do one thing. State, you can just run this code as the state is equal to, it's like the random state, right? And you can just store inside this state, because I want to append all the state inside this dictionary, right? Inside the random state, right? It's not, the spell is wrong, STATE, perfect. Okay, the third thing that I want to store is like the training score. The fourth that you can use is like the testing underscore score. Let's just use the underscore also here, right? And I'll just use the empty list because I want to append some data, right? So the training score is here, testing score is here, and let's just use the column here. Now the rest thing is like accuracy and precision score. Now, okay, so simply call this accuracy score again with the empty list, and precision score again with the empty list, right? Okay, now we are going to append all the values inside this dictionary, right? Random state, model name, training score, testing score, accuracy score, precision score, and finally the model as well. Okay, so let's just call the model ML model as well, right? And trained at, you can just use this trained at. Trained at means you have to give the date and time, right? Okay. Now let's just try to append all the values, right? So first of all, we'll use this compare dictionary. Okay, I'll use this compare dictionary. The first key that I have is the random state. So I'll just try to append the data using the state. I have stored the state value inside here, right? Okay. Now let's just copy this and do it fast. Compare dictionary, third, fourth, fifth, and sixth. Okay. Now in the second one, what we are going to do, we can just simply call the let's just call the training like the testing score you can pass, or like the training you can also give. Okay. So how to pass the like testing score? So you have this now. So just simply append this here, right? And let's just call the training score here. It's like the training score, and instead of this state, just simply copy this training score and simply paste it, right? Now the fourth one is I think the accuracy score. Okay, so let's just call the accuracy score, right? And what you want to append, it's ACC score. This is your accuracy score, and repeat the same step with the precision one, right? Precision score, and let's just quickly store this pre score, right? And the final one is like your ML model and trained at. Okay, now you want to store the ML model as well, and you are calling the model with the name of model itself, right? So you have to just simply give the model, and the final one is like train at. So for that, what you can do, you can just simply call this key, which is like the train at, and you have this method which is called date time. Inside date time, you have again the method which is called date time, and you can just simply call this now method. The now is like the current date time, right? Once you do this now, and once you run this loop, it will try to reiterate all the values using this method. It will train the values and will append all the values inside this one. Okay, perfect. Now, once we get this, so we can simply convert this compare dictionary to the final data frame, and it's like all model compare df. This is the final that we get, and what you can do, you can just simply call the pd.data frame and just simply pass this compare dictionary, right? Okay, so let's just quickly copy this, paste it here, and let's just run this, right? So target class is multi-class, but the average is binary. Okay, got the issue, right? So just copy this average one, and it say like while you're using this accuracy score or like the precision score, no? So the average should be weightage average, right? Because you're not allowed to use the binary average if you are using the multi-class problem, or if you are like particularly solving the multi-class problem. No? So it's recommended to use this average as a weighted average, right? I'm not going to like hide any errors or like any problems. You can just simply let this know, okay, these are the issues that we generally face, right? So these are the average that we will get. Okay, now let's just run this. Let's just run this. So okay, got an unexpected keyword argument average. Where is the problem, right? Okay, again there is an issue. We want to calculate the accuracy score. It's not recommended in the accuracy score. It is only for the precision or like the recall score, right? Let's just run this. Oh, again, all arrays must be of same length. Let me just check where is the issue. pd.compare. Okay, I think I have missed something. the random state model name, random state model, okay, model name. Yeah, I missed the model name, right? That is the issue. So just normally call this compare dictionary, the model name, and how to pass the model name. You know that the model name is stored with this variable. It is like the model name, right? So let's now again run this. Perfect candidate. So we are getting the final model as like at the different random state. The logistic regression is giving you the 100% accuracy. Even each model giving you the accuracy, right? So what you can do, you can just simply call this all compare model df. In this way, we can like particularly call this models, right? So just go to this all model compare df, and what you want to call the maximum score. Na? So what you can do, just simply go to this testing score and call this max, right? And this is the maximum score. It's like the one. Okay. Now what you just want those data, those who are having the maximum values, right? So for that you have to use the masking technique to particularly filter out those data set that they have the highest score, right? So we are using this masking technique, right? So we have right now two models that are having the 100% accuracy score. So let's just call this as a best model. And because we are getting the two best model now, we just only want one best model. So what you can do, you can just simply again run this best model is equals to best model dot head, and just call this one as head one, right? Now just run this best model. Okay, now we are getting only the first model as the logistic regression as the best model. This model trained as something like this. These are the date. This is the universal date and time format. That is the reason you are getting this as a 152. Right? Okay. I hope everything is clear up to this one candidate. Is there any doubts or issue related to any of the code that I am particularly writing right now? Okay. So these are the things that you have to do. Now just imagine if you're like particularly using the multi-model approach, instead of just 3 only, you have 10 different set of models, right? So you can just run the loop iteration and you have to follow the same steps, right? Okay, now we are having the best model. Okay, so what I simply want to convert this best model for the prediction function. And how to do this? We have to slice this model, right? We have to call this model now. So let's just call this model. Go to this best model, use the iloc method, and just call this 0th row. And you know that the ML model is at the -2 index, -1 and -2 index. Okay. So now just call this to -2, and this is, see why I'm not getting. Okay. The issue is you have to give the comma here, right? This is the final model that you are getting. And let's just store this inside the final model. This is the variable, right? And with the help of this final model class, you can predict your values, right? Okay. So if you want to deploy this model, now you have to save all this model, right? So the step 4 is like how to save ML model. We have already used this technique, that is by the Pickle module, right? So you have to import this Pickle. Then we'll use the file handling approach. I'll just simply say this as a best model, or instead of let's just say this as a best model, let's just say this as a Iris model dot pkl. Pkl is the extension, right? And it should be open in the write in binary or like write in bytes format. And just simply call this pickle dot dump. And what you want to dump? You want to dump your final model, right? So let's just simply dump this final model with the help of find handler, and you can run this as a print done. Okay. If everything's perfect, you'll get the done option here. And how to check where is the where is your final model? Just go to this folder. You'll get your final model here, which is like your iris model.pk. Okay. Now it's good to go, right? So we have saved this model as well, right? Now what we want, candidate? We want to deploy this model using the web app. Okay. Step 5, how to deploy ML model. So there is a solution that is called web app, and we have to use one module that is called Streamlit. Okay. Streamlit is a web app open source platform where you can simply deploy your ML model, and you can use it right now as well, right? So how to do this? First of all, you have to install this module, right? So you have to write this one extension pip install Streamlit, right? Streamlit. Once you run this, it will take some time, right? it's downloading some sort of files, already satisfied, just ignore, successfully installed, right? If you install this successfully, again run this, comment this out. Now you have successfully like installed this Streamlit. Okay, so what exactly this Streamlit is? Let me just show this, right? Streamlit is like a faster way to build and share your ML, and this is like ML data apps, and this is mainly designed for the AI, ML, and deep learning engineers, right? You can just quickly, whatever the project that we will build, or whatever the project that we'll create in upcoming days, or if you'll create any project for the like kind of prototype model, right? So you can use this Streamlit, right? This Streamlit allows you to like create a web-based solution for the client, something like this. Okay, so now let's just understand this. Okay, so if you want to write a code for the web app, so you have to use this file concept. Just go to this area and just right click on this and create a new file, and make sure the new file name should be app.py. Okay, app it is like your Python app, and .py is like the extension. Okay, now what you have to do, you have to just simply go to this, double click on that app.py, simply write this code, import Streamlit as st. Okay, so we are importing this Streamlit as st. Now st is like the aliasing that we are using. Okay, and if you're starting with this project now, so you have to give the title for your project, right? So you can just simply call this st.title, and let's just write this Iris flower classification project using ML, and let's just use some emojis for the flower. Okay, and you can use any of the flower, but it should be matched with the iris one. If you don't have, so let's just normally call any of the flower, right? Is there any iris emoji, right? Let's just go to Google and check iris emoji. If we have the iris emoji, na? Yeah, this one is the iris emoji, right? So let's just use this one, flower, and we will use this one for the iris emoji, right? Well, it is like this, not exactly look like for the iris emoji, but just for understanding we are using it. Okay, this is the title that we have given, st.title. You can just press Ctrl S. Now you have successfully created a web app that is app.py, right? Now how to check it's working or not? So just simply go to this, write this exclamation mark, and simply write this command, Streamlit run app.py. If you just shift enter, you will get some sort of localhost kind of like the things. It will give you the localhost IP address. If you just click on this localhost now, whatever the file that you have created, this will give you the overall app.py. If it is not working, this can be due to like the Google Colab issue, right? So we can directly deploy this using the GitHub account as well, right? Let me just try with the Google one. If it is not working, so I'll just directly deploy this, right? Let's just wait for a while. It's not working, right? So what you can do, because we are using the Google Colab, right? This can be like the issue. Let's just use this as external link. If again it will not work, then I can use the Jupyter offline version, which is by the Anaconda. You can use this one, or I'll just do one thing. I'll simply run the code, and I'll just upload all the code into the GitHub account, right? And by using that GitHub repository, then you can probably run your or like build your web app, right? Okay, so let's just do one thing just for now. Because this code is the streaming is not performing well. So let's just do one thing. Let's just first complete this code, right? Okay, then you can probably understand. With the help of this st.title, you are giving the title of your project, right? It's like the Iris flower classification project. Okay, now what you want to get input from your data set. Okay, so let's just call the data set, and you know that you can call the data set using this method. You have to call some modules now. So let's just call this as from sklearn.dataset, and just click on this, paste this code here, right? And simply copy this code like this one, X and Y. What we want, we just only want the all data. Just simply call this as step to load dataset, and you can just directly paste it here, right? These are the same steps, right, that we're using. See, it's giving you the error like PD is not defined, so you can just call the REST module such like import pandas matplotlib. If you want to use this matplotlib and C1 as well, so just call this one, right? See, we don't want to create the model from scratch. We are just like pasting the modules that are required in this particular development of this web app, right? Let's just save this one. Streamlit as STSQL and dataset load iris pandas numpy matplotlib C1. So we are just calling our dataset, right? Let's just comment this out. Okay, now we have this X and Y dataset. Oh, okay, what I want to create a sidebar. The sidebar is something like this one. Whatever the area that we will get is called the sidebar. Okay, let me just parallelly open the paint, right? Then you will probably understand how exactly this app will look like, right? So this is the canvas that you will get. Okay, and inside this canvas we have used this title now. And what is the title? The title is Iris Flower Classification Project using ML. So this will go to this website and it will give you the title like this one, something like this. Okay, Iris Flower Classification like this. Perfect. Okay, it should be in the center of the alignment, right? Let's just give the center alignment like this, and this is the final. Perfect, right? Okay, now this area is called the candidate sidebar area, right? This is the sidebar area, this one. Inside this sidebar area, now you can give the titles, right? So let's just go to this and simply write this as st dot sidebar. You have to use this method dot title. And what you are going to write, you can just write the select flower iris features. And you know that you have four different features, na? Supple length, supple width, petal length, and petal width. You can use this one, right? So once you run this code now, this will be something like this. Okay, I'll use this color iris, select iris flower features, right? And this area is like the sidebar area, some sort of like this. You can just reduce the size to make it more clear. Perfect, like this one. This is the sidebar area, right? And inside the sidebar area, what are we going to? We are going to create a slider. That sliders allows us to slide the range where user can take an input and can select the values, right? So you can just run a for loop for I in X. We know that X is a data frame. And if I just run a for loop, now the I will become the column name, right? So I'll get the minimum value of that particular columns. We have 4 different columns now. So the first column will be like, let me just show this data set. Where is the data set? Yes. The first column will be like the sepal length. So it will ask you for the input minimum value for the sepal length. So how you can get this? Go to this X of I and simply call this as minimum value, right? Again, copy this one. And you can just, instead of minimum, you can call the max, and let's just use this as a max function. Now you have the range, like user must select the value within the range. The first one is like the minimum and the second one is like the maximum. Now you want to take an input. So let's just create a variable answer, and you have to take an input in a form of slider. Na? So just simply write this first as a sidebar, and inside this sidebar, you will get this option, which is a slider. The slider generally asks you the label, like what you want to particularly take an input. So you can just say inside a F string, select value of I. And you know that I is just nothing. I is like the column name. So it will say select value of sepal length, select value of petal length, sepal width, and petal width, some sort of like this. Okay. We are using this F string technique, right? Select value of I. You can just save this one. And this will ask you 2 different values. The first one is minimum value and the second one is maximum value. So it's like for the range that user must select this range. So let me just pass this as the minimum value and let's just call this as a maximum value, right? So these are the value that we will get by using this sidebar technique, right? So right now we have 4 columns now. So this will run the iteration 4 times. Now during each iteration, you will get the answer. So now what you want? You want the answer to store inside this user input, right? So let's just create a variable with the name of user input. And inside this user input, you can just simply append all your answer inside this user input, right? And once you append all the data, then you will get this as a user input, right? Now let's just store this user input inside the final input. So final input is just nothing. It's like the 2D dimension of this user input, because we know that ML generally takes two-dimensional data in sort of like X features, right? So we are converting this one-dimensional unit user input to the two-dimensional final input, right? Now we have to call the model. So for that, we have stored that model using the pickle concept now. So how to call that model? Again, just go to the same concept where you have saved that model. You can just simply call this one. And this time we don't want to dump the model. This time we want to import the model, right? So just call this one, and you have to import the pickle module as well. Import pickle. Okay. Now instead of dump, now you have to write this load. And what you want to load? You want to load your file. Okay. Whatever the file that you are loading, let's just name this as a chat GPT. Okay. Now this chat GPT is responsible to predict the value. Okay. How to predict the value? You can use the chat GPT, and inside the chat GPT you will get this method which is called the predict method. Now predict method generally asks the X feature argument, right? So you can give the final input, and you know that the output that you will get is in a form of array. So you have to slice the first value, right? And this is like your the final answer. So you will get the answer in sort of like 0, 1 to index. And 0, 1 to index, you know that the first is like the setosa flower. Let me just show this. Where is the target class? Yes, the 0 index is like for the setosa, 1 index is for the versicolor, and 2 index is for the virginica. Okay, so what you want? You just want the flower name, right? So how to get the flower name? So you can just call this flower name. Just call this one target class. Okay. And once you call this target class, now the target class is like a list array where this will generally ask you the final answer. The final answer are like in a form of 0, 1, 2. Okay. So you will pass the final answer, and based on that index, it will slice the value. If the final answer is 0, it will give you the setosa. If the final answer is 1, it will give you the versicolor, and then so with the virginica as well, right? So this is the flower name that you will get. Okay. Now you want to predict the probability for the flower name as well, right? So you can just say let's just call the probability, right? So let's just write the prob is like the probability. You can call your model. The model is like stored in form of chat GPT. You can just call this predict probability, right? You'll get this method. That method is called the predict probability. Predict probability, I think. I need to check this one, right? Because the hint is not coming. So let's just call this predict probability. If it is good, yeah, this is like the predict proba. So the proba is like the predict probability. Yes, this is the predict probability. Okay, so let's just copy this. And keep this as it's like the predict proba. Proba is like the probability, and what you have to give? You have to give your data. So the data that is stored in a form of final input. Just store this data inside a final input, and this will give you the probability for each class, like for the setosa, versicolor, and the for the virginica as well. So what you can do? You can just simply make it rebel. Rebel is like for the flattened one, right? Rebel is a numpy array that will generally flatten the like 2D array, 3D array to the 1D array, right? You can just check this. Okay, this rebel is a technique. Perfect. Now once you convert this all dimension array into the 1D array, so these are the probability that you will get, right? Now what to do with this probability? Why we are getting this, right? Because we want to show the probability of the each class. So you can do one thing. You can just say for I in, or instead of directly I, let's just call this as I and j using the enumerate function. Enumerate allows us to give the index and the values as well. So you are just calling. So you will get the probability of value inside a j format, and I is like the index value, right? So why we are calling the index value? Because the index is like the flower name, and we know that we have two different flowers now, three different flowers now. So we have to use the all flowers name. The flowers name are like in a target class. So let's just call this target class. The name is like, let's just call this as the flower name. A flower is equals to target class, and you can give this as an index. So if the zero index value is 0, so it will give you the setosa. This is the flower name, and we want to predict the to print the value for the each flower. So you can just write this. If you want to show something, so you have to use the st.write, right? You can just write st.write and use this fstring method, and just simply say this probability probability of probability of the flower name. So you will get the flower name with the help of flower. Okay, the probability of flower is, and let's just call the probability. Where to get the probability? The probability we will get using the J, right? So let's just call this J, and J is like in a like in a floating format. So you can simply multiply this J with 100, and if you want to turn it to like round values, so you can just give the round values as well, right? So this is the right method. Right method allows you to write all the things, right? Okay, now what you can do, so for I and J is like the iteration using this enumerate function. Okay, we will get the probability for the each class, whatever the maximum probability that we will get. So this is the flower name, right? So you can use this as a st.success. st.success is like the final message that you will get, and you can just say this, the final prediction is, okay, let's just call this as the final predicted flower is, and just give your flower name here, right? So you can just run this. The final predicted flower is your flower name. We are using this as a fs string. So these are the complete like the things that we are creating. Okay, so what it will do, it will just give you the slider value, right? Slider 1, slider 2, and slider 3, because we have 4 different features now. So it will give you the 4 features, right? And here we will get the, like if you want to show some images, so let's just show some images here, right? So what I'll do, I'll pick the image here, and whatever the value that user will select, so we'll get the final output here in form of st.success, right? So we will get the final output here. So let's just copy this code, okay? And we have to push that code directly to the GitHub, right? So let's just save this, right? Now what you have to do, candidate, just go to this GitHub, create a repo, right? Go to this add file, not with the add file, go to your GitHub account, click on this plus, click on this new repository, right? And it's like Iris flower project. Okay, just turn on this to add readme. If you want to give any description, you can write it down. You can take help from ChatGPT to give a description, right? Okay, just click on this creating repository, and inside this repository class, what you have to do, you have to individually download each and things. Just download this one and go to this and simply click on this upload file and simply upload this file, right? Because I have used this multiple times now, that is the reason I'm getting the app4.py, right? Instead of app.py, it should be app.py, right? Now simply download this iris model.pkl as well. Okay, just go to this, call this iris model, okay, and you have successfully like uploaded the dataset, right? Okay, now the one major thing is now the Streamlit generally depends upon the multiple modules. We are using the multiple module, and Streamlit, how Streamlit should understand, okay, what are the different modules requirement here. So we have to create an additional file, and the name of that file is called the requirements.txt. This requirement.txt helps you to give the command, okay, these are the modules that you have to install before running this project. Okay, so I'll just go to this ChatGPT. I'll just say, using this modules create requirements. It should be requirements candidate, requirement.txt, right? I'll just simply paste the module. It will give me the requirement.txt code. Okay, now just simply copy this one. These are the modules that is required, right? Go to this file one, right click on this, click right click here, and go to rename, and make sure the spell that you write is like requirements, right? Requirement.txt. Now once you rename this file, it should be correct, otherwise it won't work, right? requirements, yeah, perfect. So we are going to download the Streamlit, scikit-learn, pandas, numpy, matplotlib, and the C1. Now just simply save this. So you will generally ask, like the people generally ask the question, sir, why you are not like using the Pickle? See, Pickle is a standard library. It's the by default product of the Python, right? You no need to like install this parallelly, right? So we have like simply pasted all the requirements.txt. Now just simply download this, go to this upload.pl, like the GitHub profile, and again paste your requirement.txt. See why I am getting this like 4 4, because I have performed these steps multiple times, right? So now simply just click on this commit changes, and once you click on this commit changes now, so this will take some time. Now you have to do some corrections. The correction something is like this. This should be only app.py name instead of app4.py, right? Now just click on this. You can, if you're doing this first time now, so you will not get this app4.py, right? Now just once you click on that file, you have to click on this edit option, and inside this just simply remove the additional words and click on this commit changes. Click on this commit changes. You have successfully changed this to app.py, right? Now just repeat the same step with the requirement.txt. Go to this edit option. Okay. Now just click on this and make sure it should be requirements.txt. Some people mistake and make this as a requirement, right? And even some with the small mistakes of the spells as well, right? So just keep it the same as requirement.txt. And now let's just do some commit changes and click on this commit changes. Now you have successfully changed all the file, right? So we have 4 different files. App.py, something like this, and this and that. Okay. Now, what about this read.md? Read.md is like the markdown file, right? So what you can do, you can just go to the same GPT and just say this: I have created the Iris project using multiple models like DT, RF, and logistic. Okay. Create.md file, readme. You can just write this as readme md file, right? It will give you the readme md file, and you can just copy the same md file. See, if you want to write it manually, you can write it right? Let me just show you how exactly this looks like, right? So you can just copy this one. This is the markdown file. Go to this edit option. If you want to create it from the local system, you can do this, so right? And just simply paste this here, right? This is the project overview. It's like the overall. Just save this, do the commit changes, and now just look at this. This is the empty file that exactly look like this one. Perfect, candidates. Now just go to this Iris Flower project and you have the complete app.py. App.py is like your Streamlit web file. Okay. The Iris model that they are going to use. Okay. The Streamlit going to use, this is the binary or like the bytes file. And the third one is like the requirement.txt. Now what you have to do, just go to this Streamlit, click on this free. Okay. This will open the share.streamlit.io. Click on this continue to sign in, right? You have to select this continue with the GitHub, not with the Google one, right? You can simply connect this Streamlit with the GitHub. It will directly pull the GitHub repository, whatever the code that you have published, right? Now just click on this create app. Just click on this deploy now. Just select this. Simply you can just call this Iris Flower project, right? And this will try to find the main file. You have to select the main file. And class, you can give this URL. This is the additional parameter. Okay. Now let's just change this to Iris Flower project by Ankit, right? Let me just write this. Okay. Domain is available, right? So if you just click on this deploy now, let me just copy this one. It will take some time. Now we are deploying our project, right? We are deploying our project in the Streamlit, right? Streamlit allows us to write the ML project where user can simply give the inputs and then can predict the values, right? I'll do some changes, right? I have simply just applied the basic codes right now. I'll do some changes live, and you can just simply check the live code as well, right? So this is the project that is looks like, right? You can just simply check now. We have like pick something like this. Okay, now you're getting the same thing, right? Okay, see, it's important to get the error, right? The app has encountered an error, then so original error something this, and it is like pickle.load. We're not able to import this one, like the file one. Okay, the file one is like the app.py or whatever the problem, right? Now just go to this one, click on this app.py. The model name is like the Iris, something like this. Where is the file handler? Where is the file handler? With yeah, this one, Iris model.pkl. It's like the C. The problem with the write in binary, na, it should be read in binary, right? So just go to this edit option, right? These are the minute changes. Okay, you can just simply perform. Just instead of writing this write in binary, na, just call this as read in binary. update this as commit changes. Okay, perfect. Now just click on this. Perfect. Now you can just go to this Streamlit and you are getting the final answer. Okay. Now the best part is candidate. You can just toggle these values now. Okay. Just look at this, right? It's giving you the value, right? It's changing the value, the versicolor, and you are not only getting the versicolor. Why you are getting the versicolor? Because the highest probability is towards the versicolor. That is the reason you are getting this. Okay. Now what we want to, we want some like the basic formulation here. So let's just do some changes. So we have the st.image concept. The st.image allows us to st.image allows us to like show the images as well. Okay. So now you can just click on this edit file. You can just go to this st.image, and inside this image candidate, what you can do, you can just go to Google and pick this one, right? Okay, now just right click on this or copy image address. Make sure you'll click on this copy image address, right? And now simply paste this inside the course. Make sure the course must be closed. Okay, and I want to show the same image to my sidebar as well. So let me just copy this one and go to the sidebar, paste it here. And instead of directly calling this as an image, now just simply write this as a sidebar dot image. Now just simply press Ctrl S, click on this commit changes, and the best part is you have to refresh this and you'll get the final updated value like this one. Perfect, right? Here you can check. Are you getting now, candidates? It's working perfect, yes or no? Everyone, candidates, are you getting my points? Just let me know in the message area, candidates. It's working, right? So now what you can do, you can just simply change the values, right? And if you change the value, you will get the answer, right? And you are getting the multiple probabilities, right? Based on different flavors, right? You are getting the Virginica here. Okay, so instead of directly getting the answer, now we have one method that is called the spinner method. Okay, so let me just write this as a st.spinner, right? st.spinners allows you, it will take some time. Okay, and with the set of this time period, then you can get the message, right? So I'll just simply copy this one. Okay, and just go to this, click on this edit mode. Okay, instead of directly printing this, let's just paste this code here, and then you can probably call this as st.success. And inside this success, you will get this message, right? And let's just give the time frame as the 2, and you can import the time module as well, import time. Okay, now I'll do one more thing. I'll just want to show my like the markdown as well. So I'll just go to this GPT. Okay, and I'll just say, okay, inside app.py, give me markdown for my LinkedIn or GitHub account. Okay, you can just say this, give me LinkedIn or GitHub thing, right? So this will give you the st.code where you can use this one as well, like this st.markdown. You can just take a copy of this one. This one is very easy, right? Just paste it here. You can just use this connect with one, and you can use the overall like whatever the link that you have, candidate, right? GitHub some slot of like this, your username and your username. Let me just go to my GitHub account. Where is my GitHub account? Yeah, this one. And this is like this Raj has. Let's just copy this. I'll just go to this one, and here I'll paste my username, right? Let's just paste this one, and let's just paste here, and let's just use the LinkedIn with the same name, right? Well, I don't have LinkedIn profile with this name, right? But just for basic purpose, I'm running this, right? Okay, candidate. Now let's just simply save this, do commit changes. Okay, and just go to this. Now you can just check this one. Okay, now it will take some time. Instead of directly calling this, now see, you can just check, wait for it. Okay, so the wait for is like predicting the flower. Okay, once you change the value, it will change, right? Wait for it. Okay, it will change and it will give you the maximum values. The predicted flower is the setosa. If you want to show the images for the setosa as well, so you can just do this thing, right? You can just go to the GitHub, and inside this, just go to this one, go to add file option, right? Where is the repository? Go to this Iris flower and click on this add file, click on this upload file, go to this one and upload some file. We have some file. The first one is setosa png. Okay, I'll just upload this one. and the second one is Virginica PNG. Okay, let me just call this one as the Virginica PNG, and the third one is like the versicolor PNG. Why I am calling this? Because I can show the images of the predicted flower as well. Okay, now let's just commit this changes. Okay, and what you can do, you can just simply say this. Okay, we have a mistake in this spell of this Virginica. Just simply click on this Virginica, and it should be, see, this is the image that we are getting. Just click on this edit, and let's just make this as a VIR, right? Virginica.png. Just simply press Control S or do the commit changes, right? You can do the commit changes with the Control S as well, right? Now we have successfully changed the flower name, Setosa, versicolor, Virginica, and so on and so on. Okay. Now just go to this app.py file. We want to show the final output now. Okay. So let's just show the final output here below this xt.success, right? So just click on this edit mode. Okay, just go to this and simply call your st.image, and you want to show the image now, so you have to call that image, right? How to call that image? You can give the like reference of this. Okay, and you know that the reference of this is with the flower name now. So let's just simply call the flower name. I'll just simply call the flower name inside a f string. Okay, and it should be in a lowercase, and then simply add this with the .png extension, because the file is like in a .png extension, right? So simply call this one. This is like the first, and just concatenate this with the .png, right? Once you concatenate this, this is the st.image that you will directly get from here, right? Whatever the output that you are getting, right? Just simply press Control S, apply the changes. Now go to this one. Simply it will take some time, and here the final result, right, candidate? If you just change the value now, so this will give you the final prediction as well. You're getting the final value as the Setosa. Now let's just decrease the petal width, right? See, the value is again the Setosa. Now let's just increase the petal length. Okay, so we will get this Virginica right now. Okay, so I hope everyone is getting my point, candidate. In this way, we can create this project, right? Now the best part is this is live deployed. What you can do, you can just simply copy this URL. I'll just paste this one. Guys, if you are available or like connected here, so just click on this link and open this link inside your mobile phone, or you can use the laptop as well, right? Once you click on this link now, you will get the complete live deployed website here, and it is completely deployed. You can just simply check and let me know it's working or not, right? Class, anyone can kindly just open this link. Okay, you can open this link inside mobile phone or like in the laptop as well, and just let me know very fast it's working or not, right? All the candidates, class, do it fast so that I understand, okay, this working or not, right? Is there anyone present right now? Candidates, the link already been shared with you. You can just simply open the link. The best part is, let me just open the incognito mode, and you can just paste the link here. And because it's live deployed, right? So user can simply paste this link, and this will predict the value, right? Where you can select the values by selecting the range slider, and then based on that, you will get the final answer, right? In this way, the ML engineer or the deep learning engineer have to perform different set of like concept. If you just simply click on this GitHub now, it will open you the GitHub link as well, right? This is the all about for the project that we have just simply deployed using the Streamlit. And in the previous classes, we were using this for the like basic kind of prediction function. Now this time we have used this for the Streamlit purpose, right? Is there any doubt, candidate? Just let me know. Okay, you can. Acha, okay. Okay, so Let's just close this and you can just take a reference of this candidate. Okay. Then you can probably check this. Let me just close the recording and just meet tomorrow, right?